Hi, this is part 3 of lecture 9. In this video, I will teach you how to elect a root pod from multiple equal cost path. In the previous videos, I have shown you how to elect a root pod from unequal cost path. So what it means by unequal cost path? It means that when you have two paths to go to the root bridge, so the cost for path 1 and path 2 is not the same. But there are situations where the cost for path 1 and path 2 are the same. That's why we call it as equal cost path. So when a switch has multiple equal cost paths to the root bridge, so the switch will determine a pod using three criteria. The first criteria is lowest sender BID, the second criteria is lowest sender pod priority, and the third criteria is lowest sender pod ID. So what it means by the things that need to be highlighted here is the lowest sender. So for example, we have in the situation where we have S1 is connected to S2 and also S3 through F01 and F02. So here for port F01, the sender is S3, and for port F02, the sender is S2. So I hope you understand what it means by sender. So we determine the election of the root pod based on the lowest BID between the senders. Okay, right. So now I will explain each of the criteria. So basically, I'll go for the first one, which is lowest sender BID. This diagram shows a topology with 4 switches, including S1 that has been selected as the root bridge. Because of why? Because the bridge ID, the port priority is the lowest. Okay, the port priority, the bridge priority is the lowest. Now, uh, now we also know from the diagram that S3 and S4, the port F for S3, port F01 and port F03 has been selected as the root port. Okay, why? Because these two ports, F01 of S3 and F03 of S4, has the lowest cost path and to the root bridge. Okay, so now we are left with another two segment, okay, which is trunk 2 and also trunk 4. So I'll just wipe this off first. So between these two segments, we have to select the root port on S2. Okay, so on S2, we need to select the root port because you understand according to the spanning tree protocol, we need to select root port for all non-root bridge. So S2 is also a non-root bridge, so we need to select a root port on S2. So S2 have two ports, two connected ports, which is F01 and F02. So we need to decide between F01 and F02 which one is the root port. So according to the criteria, the first criteria, which is we will choose the lowest sender BID. So basically what we need to check is what is the BID for the sender on both port. So the sender of port F02 is S3 and the sender for port F01 is S4. So if I were to compare the bridge ID of S3 and S4, it looks like S4 has the lowest bridge ID. Because you see the MAC address of S3 is 55555 and bridge ID of S4 is 1111, so it's the lowest. So because S4 has the lower BID, so the F01 for port S2 is selected as root port. Okay, So that is how we elect a root port from a multiple equal cost path. And later, you see in the last segment, which is trunk 2, so we need to decide which one is the distributed port and which one is the alternate port. So we know here, because a port F02 is has closest path to the root bridge, so that's why has the reason why this is selected as the designated port, right? Okay, and then finally, in this segment, F02 of S2 will be elected as the block port or alternate port. So I hope that it is clear. The second criteria to elect a root port from multiple equal cost path is by looking at the sender port priority. Okay, to demonstrate this criteria, so we change the topology to one where two switches, which is S1 and S4, are connected with two equal cost paths between them. So you see here, S1 and S4 is connected with two links on two ports. S1, the port is F01 and F02. S4, the port is F05 and F06. Now, if you look here, clearly S1 is the root bridge because of why it has the lowest bridge ID. Okay, so S1 is the root bridge. Now, what we're going to do, we know that all ports connected to root bridge, all connected port on root bridge will becomes a designated port. So that is clear. Now what we have to do is we need to decide the root port on S4. Okay, the root port on S4. So the criteria that we need to choose is by choosing the lowest sender port parity. So you have to know that the default port parity is 128. So you can see that both port on S1, F01 and F02 has the same priority. So meaning this is a tie. Okay. So basically, if you would like, for example, if you would like to choose, for example, F05 as the root port, just for example, if you want to manually assign F05 as root port, so what you have to do is you have to change the port parity for F02 on S1 to the lower value, which is, for example, 1. Okay, so when you set port parity F02 on S1 to 1, so F05 will automatically becomes the root port. So you can ingat, you have to remember is the lowest sender port parity. So the change need to be done on the sender port, not on the non-root bridge port. Okay, not on S4. Now, given the same example earlier on, we already knew that in this case, because if you don't change the port parity, the parity is the same for both both sender port, yeah, which is 1 to 8. Sorry. So basically, it is a tie between the port. So if it's a tie, so we will go for the third criteria, which is lowest sender port ID. So now, for example, on F06 here, for port F06, the sender port ID is F01. And for port F05 on S4, the sender port ID is F02. So mana satu? Which one is the lowest? Of course, F01 is the lowest. So because F01 is the lower port sender port ID, so F06 is selected as the root port. So because we have already select F06 as the root port, so the other port, which is F05, will become the block port. Okay, so I hope this is clear. the three I have explained the three criteria to elect root port for multiple equal course path. Now, let us look at this is also part of the STP operation. Let us look at STP timers and port states. So before I explain this, you need to understand how the operation STP operation is done is by sending BPDU frame. So what is BPDU frame? BPDU stands for Bridge Protocol Data Unit. So it is actually a data message that is transmitted across the LAN to detect loop in network. So how actually they detect the loop in network? So in the frame, in the data message, so it will in the BPDU frame, it will contain all the information about the port, the switch, the priority, port priority, and also the switch priority. Okay, so now, for the STP to converge, for the STP to converge across the networks, conversion maksudnya what it means by converge means sampailah the whole operation until they finish. They are able to achieve a loop-free network. So it requires 3 timers. The first timer is hello timer. So it is the hello time is the interval between BPDU frame. Okay. So the default is 2 seconds, but you can always modify it. And then we have forward delay timer. So what is the forward delay timer? Is the time that is spent in the listening and learning state. Okay. So basically the change of port status, from blocking to listening, from listening to learning. Okay. So this will be explained in the next slide. Okay, but what we need to understand in this section is STP requires 3 timer: hello timer, forward delay timer, and also max age timer. So max age timer is the maximum length of time that a switch waits before attempting to change the STP topology. So by default, the timer is 20 seconds, but always can be modified. Now, if you want to change the default time, so you can change it on the root bridge. So basically, the spanning tree is determined through the information learned by the exchange of the BPDU frames between the connected switch. So if there is a port transition on the switch directly from blocking state to the forwarding state. So this is the fourth state. This I will explain a little bit after this. What it means by each of the state. But if a switch port transition directly from blocking, meaning first the port is in under blocking state or on the blocking state, but it transition directly to forwarding state without information about the full topology. So basically it could create a data loop. Hence the reason why to achieve a loop-free environment, so they need to go through these four port states. Okay, these four STP port states, which is blocking, listening, learning, forwarding. Okay, dia mesti lalu go through this. Alright, so the four states is blocking. So what is blocking? Blocking tu means the port is set as a block port lah, or alternate port. So what happened here is during blocking, the port cannot participate in frame forwarding, but they actually receive the BPDU frame, but they could not forward anything. Okay, even though it says here no BPDU receive, no, it's they actually receive but they discard it. Okay, so now under listening, So after blocking, and then after waiting for 20 seconds, max age timer, max age, this is max age timer, because earlier on you have learned about 3 timer kan. So this is max age timer. So after 20 seconds, after exceeding the max age timer, so now it goes to the listening state. So what is listening state? So in listening state, the pod will receive the BPDU frame to determine the path to the root. Okay, because if they do not receive the BPDU frame and read the information, they do not know who is the path to the root bridge. Okay, so basically under listening state, actually they receive the BPDU frame and calculate the cost lah. Okay, so under learning, so then under learning, after forward delay timer, which is 15 seconds, so it will transition into learning state. Okay, so during the learning state, the switch pod will receive and process BPDU frame and prepare for forwarding. It will participate in frame forwarding. So in this state, it will populate the MAC address table, okay, but the user frame will not be forwarded to the destination in this stage. The forwarding is only done under the final state, which is forwarding. So under forwarding state, switch pod is considered part of the active topology. So the switch pod towards forwards user traffic and sends and receive BPDU frame in the forwarding state. So there is actually another state which is disabled state, but we consider it as non-operational. Okay. Now, this is the summary of what I have explained earlier on. So, basically, you see for blocking is receive only, listening can receive and send. So, this is a summary lah. So, you just can read it yourself lah. The only state where a pod is able to forward data frame is under forwarding state, because it is already, the pod is already considered active and be part of the network topology. Now, from my explanation earlier on, I explained about the STP, but you need to remember that this is the basic STP operation. As we know, STP is created, the STP algorithm is developed in 1985. At that time, STP only operates on switch that offers a single VLAN. But we know nowadays, the number of, we can create many VLANs in a switch. So it's the protocol evolves, yeah, to allow multiple VLAN in the environment. So basically, the later the spanning tree protocol evolved into per VLAN spanning tree or PVST, which is the version of STP where you can elect root bridge for a different VLAN. Okay, for different set of VLAN. So this will be explained in the next video.